Hey everybody, this is Larry, this is me going with Q3 of the bi-weekly contest 110. Minimum seconds to equalize a circular array. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one, I thought I did a pretty good time. Maybe not like super good time, but like a reasonably good time. The idea here is that n is 10 to the 5th, so you want to keep things either linear or n log n, but basically relatively fast. Like if you want to do n squared, that's too slow, obviously. So here I didn't really necessarily come up with it immediately. I was trying to figure out proof, but the idea is that if they're all the same, then you just greedily always, expand out. You could kind of think about it in reverse, in that given a number that you want, that number could kind of go out one step to the left and one step to the right? For example, if you have this thing, if you have this, and maybe I'll just add some ones. After one move, if you want to say optimize for 2, you can do 2 and 2 here, and then this 2 gets spread out. So everything gets spread out one step, right? So thinking about that, and you can prove to yourself why it is, because anything that's not that is less optimal, because then now you're racing, like, this is optimal because every cell gets changed at most once, right? So, I mean, yeah, you can also change it and then change it again without any loss of generality. But in terms of levels, right? So yeah, so my initial thought is okay. The brute force mental idea is like, okay, what if we switch them all to 1-1s? What if we switched all to 1-2s? What if you switch them all to 1s? What if you switch them all to 2s? What if you switch them all to 3s or whatever, right? So that's basically the basis. And from that, I did the spreading out kind of visualization in my head. And of course, if you do it naively, it's going to be n squared. So then now, what I thought is that, okay, the longest thing to get is just that if you kind of expand it out like virus or something, then the longest path for a number is just the one with the longest gap. And then once I think about the longest gap, I'm like, well, then you don't even care about what's in the middle. You just care about the indexes that you care about. So that's basically how I came up with that step by step in my mind. And basically, I just kind of keep track for each number x. I keep track of all the index here. I don't know why I call it q, but in any case, I keep track of all the index. And then now for every index, I just kind of look through all the adjacent elements, and because of the way we append, all the adjacent elements are going to be in order, except for maybe wrap around because it's circular. And if we have a circular, then we do this thing where we just do the math this way, and the delta is just the number of gaps, and the number of gaps round up delta by 2 is the longest thing. So that's basically the idea. And then once we have the longest thing, we now that going through all the elements, now we have the cost of using of changing every number to k. So then now we just take the min of all those numbers, and that's it. This is linear time, linear space. I know this looks very wonky, but for every one element here, there's only one element here, and and we look at each element once. I mean that all of one time. Maybe that's more precise. Constant number of time. So yeah. So linear time, linear space, and that's going to be the lower bound, at least for time. So yeah, that's all I have for this one. Let me know what you think, and you can watch me solve it live in the contest now. Probably. Well, I mean, or the example inputs, not the problem. All right, let's go. Minimum seconds to equalize a circle array. What does that mean? You circle each second. For every index, replace num sub I provided num sub I or the previous number or the biggest number. Oh. 1 second and then 2 seconds. Okay. I guess the linear thing is just to do. Yeah, okay, fine. That's not even the right thing, but okay, fine. And then what is the time? The time is the max, or the so for each one we want the maximum. Yeah, okay, that makes sense. Just end maybe. Yeah. For whatever, let's just do for I in range of right, and then now you have QK I is the current number, and then next number I plus 1 to the, oh yeah, right, and then now the delta is just right, and now it would take delta plus 1 over 2 steps. So then now we want to max this, right? So longest you gotta if maybe I have to special case it, I don't know. If this is one element, then longest is equal to n over 2. Is that true? Maybe I'm off by some stuff. I have to whoops. Okay, so if there's one space in between, okay, the 2 space is 1 to the, but this subtraction is not quite right. The number of spaces is -1. Yeah, right. And then this is the number of spaces on the. Is that true? Oh yeah, no, it'll go around, so that's fine. And then this is this one way. Because otherwise this would just go to 0. That's why, and we don't want that. If there's only one element, there's n minus 1 space. So this is actually just n over 2. Okay. Hopefully this is good 101. Well, not good at all. Why is this 1? This is 1 because longest is 1. Delta would be, this is 1. This should be 0 for all of these, right? Oh, because it loops around. I forgot to handle that case. Then it's 0 and 3. Or 3 and 0. Okay. Yeah, this is weird. If nx is less than current, nx we added to n. I think that makes it a little bit better. And then now we nx minus current. Okay, there we go. I'm just doing the. Okay, Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.